Module 7, Lesson 1, Full Cloud Native Design Patterns. Welcome back, everybody. In this module, in this lessons, we are going to finally convert our application over to a full cloud native design pattern. All right. So you may be thinking, well, we did a lot of work. We brought in DynamoDB. Where else can we go? Sure enough, let's draw it up here really quick. Here's our ELB, right? This is our ASG auto scaling group, right? We have S3, we have Dynamo here, right? We have our, also in the same subnets, we have our EC2 backend, okay, right here. And we have connecting these two, probably better drawn this way, is SQS, right, and SNS, right? That's kind of connecting out. So we have all these services here, but one thing that we want to take a look at is this, okay? Because this is a static system. It sits there, and that's kind of a static model where we have a system, we have a server, we can communicate with it, right? It's a known concept. But what if we bring in something called containers, right? Because do we really need, you know, Ubuntu server or Red Hat server here? Actually, all we need is just an OS and an application, right? We're running Python. We actually don't need a kernel and audio drivers and things like that. So in comes something called a container. Now, you've probably heard about this in other classes, but basically an OS container, okay? They've existed for a long time, starting with the BSD jails, and then to Solaris zones, right? And then eventually they kind of evolve, and in 2015, a little company called Docker really figured out that these were not really for operating, or they were not for infrastructure, but they were a way to deploy applications, okay? And so what a container is, it's a virtualized operating system. It's a fat binary that has all the tools to run just the application you need. And multiple containers sit on top of, right, one kernel, one scheduler, and they're all blocked off from each other, but they all share the same hardware. Therefore, you're not virtualizing the entire operating system, just the entire OS stack, kernel and hardware, just the OS, which is very, very small. And because that's very, very small, we can deploy it very, very fast. So this brings up a topic called Lambda, or serverless. Okay, now I always kind of chuckle at that because, of course, if you're computing, you know, you have to be using servers, right? You have to be using computers, right? But the term serverless means non-VM-based computing. How does this look? All right, well, let's draw our architecture over here. All right, so we have our ELB, okay? We have our ASG, okay? And instead of having code in our app.js to insert records, to modify things in our EC2 instance, right? What we're going to do is we are going to involve triggers, okay? So that as soon as we upload to the S3 bucket, a trigger will kick off a Lambda, and what it will do is it will spin up a container that will load the Python app code we give it, right? and it will execute, it will modify our image. Then our code will talk back to Dynamo. We'll give it permission. Okay. It will talk to SNS, right? After this has already talked to SNS. Okay. And then when it's done processing, of course, it will put the image back in the finish bucket, and it will update DynamoDB. And then once it's completed its code, it deletes itself. It shuts down. Okay. Notice now we're running compute almost as a function, whereas it was a function over here. We had to listen. Notice what other component we've gotten rid of. That's right. Okay, so in going fully cloud native, we have events trigger other events, and this is called Lambda, and we're going to be walking through how to do this, how to modify. We're going to be getting rid of even more infrastructure code, and we're going to let these triggers over HTTP, and of course, assuming you have permission, right, which we're going to give you permission, we'll be able to take the functions of our code. Now, we're not going to have to rewrite very much, or if any, of this Python app code, because we'll give it to the Lambda service and it will load it in, and it will load in the libraries as well. We can then use the exact same code we had. We don't have to change anything. We will have to remove our SQS logic because we don't need a queue, because now on demand these spin up. So the next person to launch and upload a bucket will get another Lambda function, and they'll get their Python app here, and the work will go on as many as we need. Now, this isn't very long executing. There's limitations on how much code and logic you can put here. And there's, of course, service tier levels that we're going to see in Lambda. But this is the cloud native version we want to get to. This takes advantage of all the things we've been learning. This is where we want to go. So in the coming lessons, we're going to break this down. We're going to migrate it over to this, and you will have gone through the whole gamut from legacy, cloud 1, to what we call cloud 2. Now, there's more beyond this, and I wish we had 100 classes and 100 hours to cover it. We don't, but this will get you pretty far in understanding cloud computing and what makes cloud native thinking and cloud native design. With that, we'll see you in the next one.